Let's continue solving this type of question on vectors. Question number 4, I have a parallelogram OPRQ. The position vector of P and Q are P and Q, small p and q, as you see here, this and this. X is on PR so that Px equals to, the Px is equal to 2XR. Consider XR is 1 unit, this 1 unit. So the Px will be 2 times 1, which is 2. This is 2. Now find in terms of P and Q in their simplest form the vector QX. The vector QX, this vector, is simply this, like QX is simply QO plus OP plus PX. The sum of these 3 vectors, 1, 2, and 3, gives you the vector QX. Okay, so vector QX is a negative Q. This is the opposite direction of Q vector, this. Plus this vector is P, the vector OP. And the vector Px is actually 2 parts out of 3, as you see here, 2 out of 3 of the vector PR, and the vector PR is the same as the vector OQ, which is Q. So answer is P, and negative Q plus 2/3 Q is actually negative 1/3 Q. Okay, this is the answer of OX vector. Next one is, you can write, of course, the value here, P minus 1/3 Q. Of course, you can write negative 1/3 Q plus P, no problem. But I prefer to writing the expression start with a positive term. The position vector of M, the midpoint, the M is midpoint of QX. Position vector of M is simply OM vector. So OM vector, how can you find it in terms of P and Q? Go to OM now, this vector OM now, as you see here. This vector now, OM, consider now, I can delete this part. Consider now the triangle. Okay, I did already this part. Consider now the triangle. You can write this in solution. Consider triangle OMQ, this triangle. The vector I want to find, the position vector of point M, the vector is OM, is simply OQ plus QM. The M is midpoint. This is the ratio 1-to-1 here between QM and MX. So OM vector is equal to OQ, which is Q, small, plus QM vector is 1 part out of 2 of the QX vector. QX vector already I solved in the first part, so I have Q plus half bracket P minus 1/3 Q. So the final answer is Q plus 1/2 P minus half times 1/3 is 1/6 Q, as you see here. Yes. So final answer is, continue here. So Q half minus 1/6, just multiplied by 3 here, multiplied by 3 to make it 6. So 3 minus 1 is 2/6 Q, which is 1/3 Q. So Q plus, so I have something P, something wrong here. This is different, I'm sorry. No, this one, no. This part, no. So I have P and a Q actually here. So the answer is Q plus half P minus half times 1/3 is 1/6 Q. I solved now Q with Q. Just leave half P alone, this part. And the Q minus 1/6 Q is 5/6 Q. And this is the answer of the vector OM. Okay. You can write this answer here down in all position vector of M. You can write half P plus 5 over 6Q. And it means if you want to move from O to M, you have to go half P in the direction of P plus 5 over 6Q. Like this one, let me show you. From O to M, you have to go half P like this until here, like this. And after that, you go up. This part is actually 5 over 6 of the vector Q. Remaining here, 1 over 6 here. The remaining part is 1 over 6 of the Q. So that's something like that. Okay. No need to do this. Just I want more explanation and emphasize my answer, or I want to be sure that show you that my answer is correct. Question number 5. I have P is a point 2 and 5 and a vector PQ 3 and negative 2. When I say a vector PQ 3 and negative 2, it means 3 and negative 2 represents a translation that translates P to Q. So if you want to find the terminal point of the vector Q, just add the initial point plus the translation 3 negative 2. You can write this vector as a row vector like this and just add it to the initial point to get the terminal point Q. So 2 plus 3 is 5, and 5 plus negative, this is 2, positive, I'm sorry, 3 and 2, this vector 3 and 2. No, is it negative? It's negative, yeah, it's a negative. Why not appear negative here? This is negative. So 2 plus 3 is 5, and 5 plus negative 2 is simply 3. So the answer is 3. If this one is negative, so I cannot here, just it's negative 2 here. Okay, let me be sure it's negative. Yeah, it's a negative value. Now I have a parallelogram. O is the origin and O, A, B, C is a parallelogram. M is midpoint of A, B. M midpoint, these two parts are equal, and the M is a midpoint here. OC is C and OA is 3A. OA is 3A, this vector and this vector given. CE is 1/3 CB. 1/3 CE, look at this part. CE vector is 1/3 CB vector. But CB vector, the same OA vectors, two opposite and parallel sides of parallelogram. So simply I can write 1/3 times 3A, which is A. So this vector CE is simply A, okay? And the remaining part is 2A, because the whole CB is 3A is the same as OA. Two opposite sides, as I told you, of parallelogram. The vector OB now, where is the vector OB? Yes, the vector OB, the diagonal, always the diagonal of a parallelogram is the sum of these two vectors, always like this. The OB is simply C plus 3A, or if you want to say 3A plus C, doesn't matter. Addition is commutative. Position vector of M. Position vector of M is simply OM, yes? So this vector OM, how can you find it? Now consider, I can delete this part now, this is already done. Okay. I have a vector, consider triangle OAM. Look at this triangle. In this triangle, the vector OM is simply OA vector plus AM vector. So OA is simply 3A, and the AM, because the ratio is 1:1, M is midpoint, the vector AM is simply half the vector. This one part out of two parts of the vector AB. The vector AB is the same as C. So this is simply the OM in simplest form. So the OM, the position vector of point M, is 3A plus half C. I can just write it here. 3A plus half C. And OE vector, where is the OE here? I can show it to you. OE, where is it? Yes, this vector OE. How can you find? The vector OE, I wrote already this part is A, vector A. The vector OE, consider this triangle now. So the vector OE is simply C plus A. It's quite easy. C plus A. Yes? C plus A or A plus C. This is the vector OE. Okay? But mentioned here OED, this side, OED, this side, is a straight line with OE to ED is 2 to 1. So this is 2 parts, and this is 1 part. Now the next question asks about CD vector. CD vector is really considered part of OE. It's not part, it's more than one part, one whole of OE. But you simply now, you can write now. The vector OD represent now 2 plus 1, 3 parts out of 2 parts of OE. Again, the vector you are writing here, the same its ratio written down here. Okay? You have to do this. So 3 halves, the OD now, 3 halves of OE. Let me write this. The vector OD. Written here, CD. Oh, no. Oh, I want CD. Where is CD here? Oh, I found OD first. Okay, nice. I found OD first. I need OD. So the OD is 3 halves of OE. OE already given, already found. I found it here. This vector OE is simply A plus C. So this is the vector. Now, if you want to find the CD, now consider triangle OCD. Now, triangle OCD, or in triangle OCD, the vector CD that I want to find CD now, okay? The vector CD vector, this vector is simply CO, which is negative C, plus OD that I found it now, this. 3 halves A plus 3 halves C by using distributive property. Just I multiply 3.5 into A and C together. So now I have 3 halves A, and the negative C plus 3 halves C is simply half C, half C. Okay, because it's negative 2 over 2, is it? Yes. So the answer of CD is 3 halves A. Okay, CD 3 halves A. I can write it here. 3 halves A plus 1/2 C. Write down 2 facts about CD and OB. Now CD, I can just take half common factor. I leave it 3A plus C inside. This is the vector CD. And the other vector OB, I found it before, 3A plus C or C plus 3A. Look, now 3A plus C is the same vector OB now. So just if we rewrite half again, and instead of 3A plus C, just write the vector OB. Now, the vector CD is a scalar multiplied by the vector OB. It means that the 2 vectors are parallel. Factor number 1, that CD line segment is parallel to OB line segment, and CD as a segment, its length is half OB. Just rewrite the same sentence here for vectors without the symbol, of vectors. Give you the relation between their lengths direct. CD is half OB, like this one. CD, this side, half OB. If OB like 10 centimeters, this is only 5 centimeters. This is what we found now by using vectors. Okay? And last question in our video today about this shape. I have this figure. C is midpoint of AB, the ratio 1 to 1, something like that. And the B is midpoint of AD. The ratio now is this one represent 2 units because the AB is 1 plus 1, 2. So the BD must be 2. They are equal. BD equals AB. And I'm asking now, 2 vectors are named for you, A and B. Find in terms of A and B, find the position vector of C. Position vector of any point, it means the origin to this point, OC. where is the OC here? Yes, this vector OC is simply, you can first consider this triangle. Okay. طبعا in triangle OAB, the vector AB is simply AO, that is negative A, plus OC, OB, which is B. Okay, so AC vector is half this one. So in triangle OAC, in this triangle there, shaded one, the vector OC equals OA plus AC vector. We solved like this many questions. OA is simply A, but AC now is one part out of two of the AB. AB already given here, negative A plus B. Okay, simplify this part. You have A minus half A plus half B. So the final answer is half A plus 1/2 B. This is the OC. Okay. The vector CD, yes. If you look at vector CD, this vector CD really is 3 parts. CD vector is 3 parts out of 2 parts of the vector AB. I use this ratio now, or this equation, because the vector AB, I have it already. The vector AB is simply, I did it before, is negative A plus B. The vector, I just write it in this side. The vector AB coming from the triangle OAB as negative A plus B. So come back here. So 3, 2 into the vector AB is negative A plus B. That's it. Okay. So this answer is negative 3/2 A plus 3/2 B. Thank you. That's it. This is the vector CD now. Okay. You can write the answer here. Negative 3/2 A plus 3/2 B. It means when you move from the vector, the point C to D, the same moving, negative 3A. Let me delete this all. Okay. And show you this part. Okay. This is, I'm using now vectors to prove this part for you. Okay. So the vector, this vector CD, this vector is the same as negative 3/2 means 1/2 time in negative A. It means 1/2 when you move from point C 1/2 time in negative. This is A 1/2 time like this, like A. This is negative A now. 1/2 time like more than half, like this. 1/2 time like this. This is negative 3A plus 1/2 of B. This is a B. If you go 1/2 time like this, you reach the point. This is the meaning of what we said now. This vector now going down negative 3/2 A, and this one is 3.5 or 1/2 time of vector B. This B, for example, this is 10, this is 15, like this. 1.5 time of it. This is the vector CD. Thank you so much. See you next time. Goodbye.